Hi, I'm Travis Nerona.
And I'm Nixon Cariello. And welcome to the History of Physiques.
Sorry folks, we've had a bit of a misunderstanding. It is the history of physics, not physiques.
Here is a brief list of things that are related to physics. Did you get all that? Too bad.
Before we go on to tell you about its history, we must first answer the question, what is physics?
Physics is the interaction of matter in the universe.
Physics is how matter in the universe interacts with other matter.
Physics is actually difficult to completely explain because it overlaps with all other sciences.
Technically, there is no history of physics because it has always existed and always will exist. But we have to start somewhere.
So let's start with numbers. Counting originated in Swaziland in 35,000 BC.
Counting is important because physics is completely based on values such as vectors and scalars. What are those? Doesn't matter. Let's move on.
Astronomy was the next big movement in the study of the universe, but somewhere between counting and astronomy was the implementation of number systems for measurements.
This all may seem a bit confusing, but number systems, measurements, and values set a foundation for other foundations of physics.
Astronomy was immediately used to navigate the Earth and develop calendars.
Speaking of astronomy, in the year 240 BC, Eratosthenes of Alexandria was able to calculate the circumference of the Earth after observing the way the sun cast a shadow on two wells 800 kilometers apart at the same time of day.
If the world was flat, the shadows would be the same distances, but due to the curvature of the Earth, the distances were different.
Now, let's back up a little to the year 350 BC.
A Greek philosopher by the name of Aristotle taught that heavier objects fall faster than lighter objects.
Although not entirely accurate, this was the first observation of gravity from a scientific point of view.
Someone who did get gravity right is Galileo Galilei, an Italian astronomer. He concluded that objects of different masses fall at the same rate. This was demonstrated by dropping two cannonballs off the top of the Leaning Tower of Pisa, and he found that they landed at the same time.
The next physicist on our list is Wilbur Snell of the Netherlands. He is known for the law of refraction.
This is Snell's law.
Moving on, English mathematician Sir Isaac Newton contributed three major ideas to physics that we still use today.
Number one!
Newton's first law of motion states that an object in motion tends to stay in motion and an object at rest tends to stay at rest unless acted upon by an outside force.
Number two!
The second law of motion states that force equals mass times acceleration. This means a heavier object moving with the same acceleration as a lighter object will have more force than the lighter object.
Number three!
This law states that for every action, there is an equal and opposite reaction. Newton's laws have contributed tremendously to the future mastery of mechanics, involving pulleys, levies, gears, ramps, pendulums, whatever. Newton's your guy.
Newton. This
Benjamin Franklin, the first physicist of the New World, discovered that there were two moving charges of electricity, positive and negative.
Franklin also invented the lightning rod to protect the residents from lightning.
Understanding the mannerisms of electricity is what has granted us our electronics today. Now moving on to the next... I have a tennis ball! Now moving on to the Scottish inventor James Watt. He improved the design for the steam engine, which propelled the 19th century industrial revolution.
The original design belonged to Joseph Black, a physicist studying thermodynamics.
There are two laws of thermodynamics. The first law states that energy input always equals energy output.
The second law states higher quality energy goes to lower quality energy. Now, these two ideas may seem a bit conflicted, because why would you get low energy from high energy if input equals output? It's simple. A lot of energy is lost during transfer due to heat, just like your body is radiating heat right now.
Joseph Black was one of the first people to study thermodynamics, but Count Alessandro Volta pioneered the study of electricity and ended up inventing the first electric battery.
The next physicist is Thomas Young. Born in 1773 England, he decided to study electrons and light rather than electricity.
He was able to disprove Newton's theory that claimed light travels in a consistent path of particles, but in fact, it moves as a wave.
Around this time, there were numerous studies involving electromagnetism. In 1820, Hans Christian
Andersen.
No, Travis. He wrote Frozen and the Little Mermaid. This was Ørsted, and he discovered the phenomenon of how a compass needle will deflect when brought towards a flowing electrical current.
With this new discovery, Michael Faraday was able to figure out that two metals with different charge rotating around one another would create an electromagnetic field and generate electricity. Thus, the first electric motor was born.
And that's where the fun began. Johann Carl Friedrich Gauss established the Gauss law, which states that the amount of an electromagnetic field surrounding a wire is directly proportional to the amount of electricity flowing through the wire.
Gauss continually contributed to physics with advancements in geometry, the number theory, calculating planetary orbits, and terrestrial magnetism theory.
Back to currents of electricity. A very important principle known as Ohm's law gives physicists the equation voltage equals current times resistance.
What does that even mean? Well, voltage is used to determine power, which we commonly refer to as energy.
Believe it or not, energy doesn't have much to do with electricity. Energy is the amount of work measured by heat, light, or mechanical means.
James Prescott Joule was the first person to find the equivalence of heat energy to mechanical energy. This value is known as the joule. In America, we use calories, a measurement of energy from food intake.
In the late 1800s, William Thomson created a uniform temperature scale specifically designed for the use of all physicists.
This scale eventually became known as the Kelvin scale, and scientists use it today to experiment at the quantum level.
The quantum theory.
A physical theory that states only certain properties and events take place in discrete amounts, essentially subatomic particles.
Studying quantum physics can be difficult at times, and for areas of physics that cannot be studied, theoretical physics was born. We think.
This particular field of physics has to do with the what-ifs of the physical world. It is where testing ends and imagination takes over.
Even though these ideas are abstract, it doesn't mean that this isn't a reliable science.
Physicists spend their entire careers researching and trying to prove that their theories are in fact plausible.
Some of the most famous theoretical physicists are Albert Einstein, Stephen Hawking, and Michio Kaku.
Albert Einstein, a Jewish physicist of the 1940s, established an important concept known as the theory of relativity. It claims that time and space are not fixed as you approach the speed of light.
Einstein conducted thought experiments, or what-if scenarios. His most famous thought experiment involved two twins. One left Earth at the speed of light, and when he returned, he was younger than the twin that stayed on planet Earth.
Stephen Hawking, the most famous scientist alive, developed a theory known as black hole theory. It states that at a singular point in space, known as a singularity, there is endless gravity and will eventually swallow up everything in the universe.
This singularity will contain all the mass in the universe, and given enough time, it will explode in a big bang.
Higgs boson.
The God particle.
It is both the alpha
And the omega.
the subatomic particle of subatomic particles.
Theorized by Michio Kaku.
It's the foundation of string theory.
This particle can explain physics in one